Hello, my name is Garrett Reed, and I'm a research engineer here at WSP. Today, I will be talking about new building methods to reduce damage from earthquakes. So, to start out, I'm going to review how natural disasters, more specifically earthquakes, have affected California, go over the new building methods, and pros and cons to each of the building methods. So, first off, um, California is known for earthquakes. They have approximately 100 small scale earthquakes a day. Over the past 10 years, there's been 12 earthquakes that have reached a magnitude of at least 5, the highest being in El Mayor Cupa in Baja California with a magnitude of 7.2. At the site of the earthquake, liquidification was widespread, causing damages to farmlands, highways, and buildings. Liquidification is when soil turns into a liquid-like mass from extreme seismic activity. Over the past year alone, rebuilding costs from earthquakes has been $5.6 billion. So my first building method is base isolation. Base isolation is when you essentially lift the building to give the foundation the necessary flexibility to survive seismic activity. There are 6 major types of isolation devices: electromagnetic bearings, high damping bearings, lead rubber bearings, flat slider bearings, curved slider bearings, and ball and roller bearings. The most popular application is the lead bearing. This bearing is made of a lead core wrapped in alternating layers of steel and rubber. The lead is a malleable surface and will allow the flexibility needed for the building to flex when a earthquake is occurring. Some benefits to this application is easily installed into the new design of buildings and is very effective at reducing damages to buildings during earthquakes. Some drawbacks: it can only be applied to new buildings and cannot be added onto existing buildings. The next building method is damper rods. These rods will act as a shock absorber to the earthquake's force. The main types of dampening rods are viscous dampers and friction dampers. Viscous dampers displace the energy through the motion of a piston pushing against the fluid inside the cylinder. Friction dampers are designed to slip before the building loses any structural integrity. Some benefits to these can be installed to new or existing buildings and can be easily installed. Some cons will only help with small seismic loading. My third building method is the invisible cloak. Invisible cloaks have yet to be in practice, but essentially is a plastic and concrete rings that are placed around the building underground to divert the seismic forces around the building instead of affecting the building directly. Some benefits: it'll reduce the damage of the building, but the cons are it's never been implemented, so we're unsure, and the amount of space needed for the rings is far greater than any other building method, and can only be implemented in rural areas. My last building method is the interior protection building method. There are 4 major implements to interior protection: shear walls, cross braces, diaphragms, and moment resisting frames. Shear walls and cross braces transfer the moment away from the foundation, while diaphragms divert forces to columns and walls by removing tension from the floor and transferring the force to vertical structures. Moment resisting frames help keep joints rigid while allowing the structure to bend but not break. Some benefits: easily applied to new buildings and designs, and some cons: they can't be implemented into old buildings as easy as dampening rods, but can be implemented into old buildings if necessary. Are there any questions?